Welcome to the Deep Dive for Factory English, Episode 3. Today we are going to talk about a critical topic in manufacturing equipment. Imagine walking onto a factory floor for the very first time. It's just an overwhelming sensory experience.
Well, absolutely. It's totally deafening, right?
Yeah, exactly. You've got sparks flying from welding stations and massive robotic arms swinging with terrifying speed.
Right, and thousands of pounds of steel just moving on conveyors right above your head.
Exactly. And in that kind of high-stakes environment, misunderstanding a single word from your floor manager isn't just confusing. It can grind production to a complete halt. Or, well, worse, it can be really dangerous.
Yeah, that is the reality of the floor. There's standard, everyday conversational English, and then there is factory English. It operates almost like its own highly specialized dialect,
Right. And today's deep dive is custom tailored specifically for you, the ESL professional working in the manufacturing field. Our mission today is to break down the language of the factory floor so you can confidently use these terms in safety meetings or performance reviews and just everyday shift communication.
Because mastering this vocabulary means you aren't just, translating words in your head. You're actually understanding the physical mechanics of your workplace.
So to give us a solid foundation, we're going to look at a core text that defines the various categories of factory equipment. We'll start with the full, uninterrupted reading of the source material.
Yeah, listening to a continuous flow of English like this is excellent ear training. It lets you absorb the rhythm and the cadence and professional tone of the language before we really put it under a microscope.
Okay, great. So I'll read the opening and we will just alternate from there. Equipment refers to tangible, durable assets used in industrial processes to transform raw materials into finished products.
It includes machinery, systems, tools, and devices for production, material handling, quality control, and maintenance. Here are some examples to illustrate.
To move things around, conveyor belts are used to transport items along an assembly line, and forklifts are used to move heavy loads.
To change or shape materials, lathes and milling machines for cutting and shaping metal, presses for forming materials, and grinders for smoothing surfaces.
To put things together, welding machines for joining materials, and industrial robots for automated assembly.
To check the quality, testers are used to ensure that products meet the required standards.
To store and manage materials, industrial storage tanks are used for bulk storage.
In short, manufacturing equipment is essentially the backbone of a factory, enabling it to produce goods efficiently, precisely, and safely.
Okay, wow. That professional tone is exactly what you'd hear in higher level management meetings or maybe read in an operations manual.
Oh, for sure. Very textbook.
Right. But reading it is one thing, and owning the vocabulary is another. Let's unpack the mechanics of this language, starting with that big picture definition.
Sounds good.
So the opening line states, equipment refers to tangible, durable assets used in industrial processes to transform raw materials into finished products.
Yeah, the foundational phrase right there is tangible, durable assets. If you are working on the floor, you really need to understand the weight of those three words together.
Right. Let's break those down.
So tangible simply means something that exists in a physical space. You can touch it, it takes up floor space, it has actual physical mass.
Okay, makes sense. And then durable.
Well, durable adds a really specific layer of meaning in a manufacturing context. In regular life, a pair of hiking boots might be durable. But in a factory, durable means it is engineered to survive, like continuous thermal shock, relentless vibration, corrosive chemicals.
Oh, wow. So heavy-duty stuff.
Exactly.
Yeah.
Running 24 hours a day without catastrophic failure. That's durable. And an asset is just a business term for something valuable the company owns.
Right. So I actually want to test this definition of tangible, just to draw a really clear boundary here.
Okay, go for it.
My instinct is, well, if a factory spends $1 million on a highly advanced AI-driven software program to regulate their power grids, that software feels like their most critical equipment.
Yeah.
But by this specific definition, because I can't, physically knock my knuckles against a line of computer code, it doesn't count. Is that right?
Yeah, that is exactly the crucial distinction the text is making. Software is an incredibly valuable asset, obviously, but software is intangible.
Right. You can't touch it.
Precisely. When a floor manager talks about equipment, they are referring specifically to the physical hardware. They mean the steel casings, the hydraulic pumps, the actual physical devices just taking a beating out on the floor.
Okay, that clarifies it perfectly. And then the text explains the ultimate purpose of this hardware. It says it's used to transform raw materials into finished products.
Yeah, so transform raw materials into finished products is what we call a foundational collocation of manufacturing.
A collocation being like words that just naturally go together.
Exactly. Words that native English speakers just habitually group together. Raw materials refers to the base, unprocessed supply. We aren't just talking about a piece of metal here. We are talking about 10-ton coils of aluminum or giant silos full of microscopic plastic pellets.
Wow. Yeah.
Okay.
And the verb transform.
The verb transform is key because manufacturing rarely just, moves things around. It forces a complete physical or chemical metamorphosis.
Right.
You take a liquid polymer, you add intense heat and pressure, and you literally transform it into a solid car bumper.
That's a great image. And then the text breaks down where all this equipment lives, listing machinery for production, material handling, quality control, and maintenance.
Yeah.
Production, quality, maintenance. Those are pretty self-explanatory, I think. But material handling sounds, I don't know, deceptively simple. It sounds like a guy just picking up a cardboard box and walking it across a room.
Yeah, the phrase drastically undersells the reality of it. I mean, material handling in a modern factory is this complex logistical science of moving millions of pounds of mass safely and efficiently.
Millions of pounds?
Literally. If the physical supply of raw materials stops moving for even 3 minutes, a multi-million-dollar production line just sits idle. It's a highly choreographed ballet of heavy machinery.
Okay, so if material handling is the science of moving these mountains of raw supplies, let's look at the physical tools that actually execute that movement.
Right.
The text explicitly states, to move things around, conveyor belts are used to transport items along an assembly line, and forklifts are used to move heavy loads.
So the vocabulary of movement here is very specific. Conveyor belts operate on a continuous loop, carrying items from station A to station B. But notice the text pairs them with the phrase, transport items along an assembly line. This brings up a really critical preposition rule for workplace communication.
Oh, yeah. ESL learners definitely want to pay attention to this.
Yeah, you will hear native speakers say on the assembly line, not in the assembly line.
Because the line itself is like a physical path or a surface. If you say in the line, it sounds like you were standing in a queue at a grocery store waiting to pay. Right.
Precisely. If a supervisor is deploying workers, they will say, hey, we need 3 more hands on the assembly line.
Got it. On the line.
Yep. And the other moving tool mentioned is the forklift, which is used to move heavy loads. Now, in professional warehouse and factory English, you rarely refer to pallets of goods as heavy things or big items.
Right, you call them loads.
Exactly. It implies a calculated amount of weight that a machine is officially rated to carry.
Okay, so we've successfully moved our raw, unshaped metal to a workstation. How do we turn a useless block of steel into a recognizable part?
This is where shaping comes in.
Right. The text introduces our shaping equipment. To change or shape materials, lathes, and milling machines for cutting and shaping metal, presses for forming materials, and grinders for smoothing surfaces.
Let's focus on lathes and milling machines for a second. For anyone who hasn't worked directly in machining, these can be really difficult to conceptualize just from the vocabulary word.
Yeah, totally.
Both are designed for the specific action of cutting and shaping metal, but they actually operate on inverse physical principles.
Okay, wait. I always think a good mental image for a lathe is like a high-tech metal cutting version of a potter's wheel.
Oh, that's good.
Yeah, like on a potter's wheel, you put a lump of clay in the center, the table spins extremely fast, and you hold a static tool against the clay to carve out a bowl. Is that helpful?
A potter's wheel is the perfect analogy. The only difference is that instead of wet clay, a lathe spins a solid cylinder of titanium or steel at 1,000 revolutions per minute. And then the worker, or the computer program, presses a stationary carbide cutting tool into that spinning metal. It shaves off these ribbons of steel to create a perfectly round shape, like a heavy-duty bolt or an engine shaft.
Okay, so the metal spins and the tool sits still.
Right. Now, a milling machine does the exact opposite.
Oh, I see.
Yeah, the block of metal gets clamped down really tightly so it cannot move at all. And the cutting tool itself is what spins at high speeds, plunging down into the metal to carve out holes or slots or make flat surfaces.
That makes so much sense. Real quick, just a pronunciation note for the floor. The word lathes is spelled L-A-T-H-E-S. The A is a long sound, and the TH actually vibrates in your throat. It rhymes with the word bathes.
Good catch, yeah.
Right, so it's not pronounced with a soft A like laths. It's lathes.
Lathes, exactly. So moving from cutting to forming, the text mentions presses for forming materials.
Right.
Notice the shift in verbs there. We went from cutting to forming. A press generally doesn't cut metal away. It reshapes it using just immense physical force.
Like squishing it.
Pretty much. Think of a massive hydraulic machine dropping thousands of tons of pressure onto a flat sheet of steel, forcing the molecular bonds to bend until it suddenly takes the shape of a car door. That is forming.
Wow. And then finally we have grinders for smoothing surfaces. Because when metal is cut or pressed, it often leaves these microscopic, sharp edges, right? What are they called? Burrs?
Burrs, exactly. Smoothing takes away those imperfections so the part is structurally sound and, actually safe for the next worker to handle with their hands.
Okay, so we've taken raw material, moved it on a conveyor, shaped it perfectly using a lathe and a grinder. But a pile of perfectly shaped, loose metal isn't a finished product yet. It's just a pile of parts.
Right, it doesn't do anything yet.
So how do we turn these loose pieces into a single permanent structure that, won't vibrate apart when the customer uses it?
Which brings us to assembling.
Right. The text says to put things together, welding machines for jutting materials, and industrial robots for automated assembly.
Let's analyze welding machines and the phrase joining materials. Because in everyday English, joining might mean gluing or taping or tying things together.
Yeah, like joining two pieces of paper.
Exactly. But in manufacturing, joining implies a deep structural bond. Welding doesn't just stick two pieces of metal together. It introduces so much concentrated electrical heat that the molecular structure of both metal pieces literally melts into a shared glowing pool.
Right. It becomes liquid.
Yeah, and when that pool cools a second later, those two separate pieces have fundamentally become one continuous piece of solid metal.
That's intense. And the text pairs this joining process with industrial robots for automated assembly. I feel like automated is arguably the defining word of the modern industrial revolution.
Oh, without a doubt. It is the massive shift away from human physical labor for repetitive tasks. Automated assembly means the machinery operates independently. It's governed by software, executing the exact same physical movement 10,000 times a shift.
What?
Industrial robots handle the heavy lifting and the highly repetitive, ergonomically dangerous tasks, and that allows the human workers to focus on programming, troubleshooting, and oversight.
Right, moving the humans out of harm's way.
Exactly.
Okay, so now that the parts are permanently joined and assembled, we arrive at a really critical phase. The text states, to check the quality, testers are used to ensure that products meet the required standards.
Yeah, quality control.
So I actually want to push back on the usage of the word testers here as a piece of equipment.
Oh, really? Why is that?
Well, in conversational English, a tester is a person, right? Like she is a video game tester or he is a beta tester. But this text firmly groups testers as physical machinery.
Right. Right. That just shows how technological advancement literally changes our vocabulary. I mean, historically, yes, a tester was a human inspector walking the floor with a clipboard and a measuring tape.
Right, exactly.
But humans suffer from fatigue. A human inspecting their 1,000th part at the end of a 12-hour shift, they might miss a hairline fracture.
Yeah, definitely would.
So modern factory English uses testers to describe physical diagnostic machinery. We're talking about optical laser scanners that measure tolerances down to the micron, or pneumatic arms that violently bend a welded joint to objectively verify its structural integrity.
Okay, I see.
Yeah, machines do not get tired, making the testing entirely objective.
And the verb used alongside these objective machines is ensure. Testers are used to ensure that products meet standards. That's a great word for ESL learners to know.
Oh, ensure is an incredibly powerful verb to add to your professional vocabulary. It basically means to make absolutely certain that a specific outcome happens.
Right.
Using ensure really elevates your workplace communication. Like instead of telling your manager, I checked the machine so it won't break, you can say, I calibrated the sensors to ensure precise cutting.
Oh, that sounds so much more professional.
Exactly. It projects confidence and accountability.
And it pairs beautifully with the phrase, meet the required standards. I love that phrasing. You don't pass a manufacturing standard. You don't win a standard. You meet it. Standards are like the strict mathematical parameters dictating whether a product is legally and structurally safe to sell.
And once the product actually meets those standards, it needs to go somewhere, right? The text finishes the physical life cycle by saying, to store and manage materials, industrial storage tanks are used for bulk storage.
Bulk storage. That's a very standard logistics phrase. It refers to a massive quantity of material that hasn't been individually packaged into consumer-sized units yet.
Yeah, you don't put bulk material on a normal shelf. If your factory uses liquid resin, bulk storage means a 50,000-gallon steel tank sitting outside the facility.
Right.
If you process grain, bulk storage is a massive concrete silo. The equipment just has to be scaled to the sheer volume of the material.
Makes total sense.
Yeah.
So we have now tracked the entire physical evolution of a product. We brought in the raw material, we transported it, subjected it to the extreme forces of shaping, melted it together during assembly, laser scanned it for quality, and stored it.
Quite the journey.
Yeah. Which brings us to the text concluding synthesis. The final sentence reads, in short, manufacturing equipment is essentially the backbone of a factory, enabling it to produce goods efficiently, precisely, and safely.
Let's start in that transition there. In short, it is a highly effective rhetorical tool. When you are giving a long presentation or maybe writing an end-of-shift report, using in short signals to your audience that you are distilling all the previous complex data into one primary takeaway.
I love that. And the primary takeaway here relies on a metaphor. It calls the equipment the backbone of a factory. It's a common phrase, sure, but think about why backbone is the exact right anatomical word here.
How do you mean?
Well, a backbone doesn't make the creative decisions, right? That's the brain.
Yeah.
And it doesn't do the actual muscular lifting, but it dictates the absolute structural capacity of the entire body. Why do they call it the brain or the heart?
Ah, I see what you're saying. That is the perfect operational way to view it. I mean, if a factory's physical conveyor belts and lathes can only safely process, say, 100 units an hour, it simply does not matter how brilliant the management team's strategy is.
Right.
Or how fast the floor workers hustle. The physical hardware sets the ultimate limit of the entire business. Without the rigid structure of that backbone, the factory is literally just an empty warehouse with a lot of good ideas, but zero actual production capacity.
Wow, yes. The backbone provides the structure so the work can actually get done. And the text defines the execution of that work using 3 critical adverbs: efficiently, precisely, and safely.
Yeah, these are huge.
If you are an ESL learner looking to advance in your career, do not treat these as just vocabulary words. These 3 adverbs are essentially the universal metric for success on any factory floor in the world.
Absolutely. They are the exact performance indicators your floor manager uses to evaluate the entire operation.
So let's start with efficiently.
Well, efficiency in manufacturing basically means generating maximum output with minimum wasted resources.
Oh, yeah.
It means the machines are running without constantly breaking down. The conveyor belts are perfectly timed so no station is just sitting there waiting for parts. And energy isn't being wasted. If a machine isn't efficient, it just destroys the company's profit margin.
Right. Time is money, literally. And then the second metric is precisely. Precision is about exact, repeatable accuracy, right?
Yes. When we discussed the lathe shaving ribbons of steel off a spinning block earlier, it wasn't just making a rough shape. It was carving it down to the exact millimeter specified in the engineering blueprint.
Right, because if a part isn't manufactured precisely,
it will literally jam the industrial robots during the automated assembly phase. The whole line stops.
Which is exactly why those diagnostic testers we talked about are required to ensure the standards are met.
Exactly. And the final adverb is really the foundation of everything else: safely.
Yeah, the most important one.
A factory floor is inherently hostile to the human body. There are heavy loads suspended in the air, extreme thermal heat from welding pools, blades spinning at thousands of revolutions per minute.
It's dangerous.
Highly dangerous. The equipment must be designed, maintained, and operated safely so that every single worker clocks out and goes home to their family physically intact.
Efficiently, precisely, safely. If a piece of equipment fails at any of those 3 metrics, it basically becomes a liability rather than an asset.
Exactly. And if you can confidently use these terms to describe your own workflow during a performance review, you are speaking the exact same language as your factory leadership. You are demonstrating that you understand the big picture.
That's such a great point. Well, we have covered a massive amount of technical and operational ground today. Let's solidify those core takeaways. We established that equipment is defined as tangible, durable assets. the resilient physical hardware built to survive the brutal conditions of industrial production.
Right.
And we track the 5 functional categories of this equipment: moving mass via conveyors and forklifts, shaping metal using the extreme forces of lathes, mills, presses, and grinders, joining pieces structurally with welding machines and automated robots, objectively verifying quality with diagnostic testers, and finally, containing massive volumes of product in bulk storage tanks.
Beautiful summary. And we discovered that all of this physical hardware serves as the backbone of the entire operation, dictating the factory's capacity to transform raw materials into finished goods.
Exactly.
Our call to action for you, the listener, is to take this framework directly onto the floor during your next shift.
Yeah, put it in practice.
Don't just look at the machines as a collection of noisy, intimidating metal. Analyze your environment. Look at a specific workstation and silently categorize it. Ask yourself, is this machine engineered to transport, to form, to join, or to test?
Oh, that's a great exercise.
Identifying the specific mechanical purpose of the machinery in plain English will drastically accelerate your confidence in the workplace. Turning your daily environment into an active language laboratory is really the fastest way to achieve fluency.
I couldn't agree more. Before we sign off, we want to leave you with one final provocative question to analyze on your own time.
Okay, let's hear it.
Think about the physical layout of your specific workplace, or maybe a production line you are familiar with. If you were suddenly given the budget and the authority to completely upgrade just one of the 5 categories of equipment we talked about, either the movement, shaping, assembling, testing, or storage, to make the entire facility run more efficiently, precisely, and safely, which category would you choose to upgrade?
Oh, that's a brilliant question. Evaluating that forces you to think like an operations director.
Right.
It requires you to look past your individual station and identify the biggest systemic bottleneck in the entire production chain.
Exactly. Take that perspective with you. Keep analyzing the physical mechanics around you, keep expanding your factory English, and keep communicating with confidence. We will see you on the next Deep Dive.